Hello learners, welcome to our Senior Secondary Environmental Science course of NIOS. Energy is the capacity to work and power is the rate of energy delivery. Energy is essential for most activities of modern society. Its use or consumption is generally taken as an index of a standard of living. We use energy in the form of fire, wood, fossil fuels and electricity to make life comfortable and convenient. At home, we use electricity for our lights and fans, air conditioner, water heater and room heaters, oven, microwave, washing machine and dryer, etc. We use diesel, petrol, CNG for our cars, buses and autos, etc. Large amount of energy is consumed in agriculture and industry. In offices, we use energy to run air conditioners, fans, lights, computers, copying machine, etc. We use fossil fuel to run buses, trucks, trains, aeroplanes, ships, etc. and thus transportation uses a large percentage of the all energy used. During this program, we will learn about the role of energy in society. It's lesson 27B of module 8B of your environmental science course. I am Neelam Gupta, course coordinator of environmental science. Welcome you in this program. For this discussion, we have with us Dr. Padmaja Saxena, assistant professor, Dayal Singh College, University of Delhi. Welcome you, madam.
Thank you, Neelam. So, today we are going to discuss the topic the importance of energy, and as we all know that energy is required for our day to day need, there are different types of laws which we have to follow and different resources for the energy. So, the objective for today's topics are explanation of the concept of energy, the importance of energy for human society, then explanation of first and the second law of thermodynamics and different sources of energy. So, now let us begin the lesson by defining what is energy. Energy is the ability to do work, and energy from the sun gives us the light during the day. It dries our clothes when they are hanging outside on a clothesline. It helps plants and crops to grow. Energy is stored in plants, is eaten by animals which are the herbivores and providing them the energy. Then predators which feed on the herbivores, they give them energy. When we eat food, our bodies transform the energy stored in the food into energy to do work. When we talk, run or walk, think or read, we burn food energy in our bodies. But where does the energy come from? There are laws which govern the energy. So, the laws which govern the energy are the first law of thermodynamics, which deals with conservation of energy. It states that energy cannot be created or destroyed, but can only change from one form to another form. For example, the energy of the sunlight is absorbed by the green plants during the process of photosynthesis, and this solar energy is stored as chemical energy in the form of food or biomass. The second law of thermodynamics, which states that in every energy transformation, some energy is always lost in the form of heat, which is unavailable to do further useful work. In other words, no energy transformation is 100% efficient. Heat is familiar to everyone because we all know how it feels in hot summer and cold winter days. The degree of hotness of a body can be measured with a thermometer, which contains a fluid, which is usually mercury, that expands as the temperature rises. Heat is one of the many forms of energy that can take, and heat is one form of energy into which all other forms of energy can be fully converted. The unit of heat is calories or joule and is used to express the amount of energy. A gram calorie, it is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade, and is the unit in which energy value of food or any other organic matter is expressed, although it is now being replaced by joules. joules, which is represented by capital letter J, a practical unit of work. It is derived SI unit of energy or work, being the work done when a force of 1 Newton displaces the point by 1 meter. Sources of energy. It is important for us to know about the various sources of energy as it is essential for us in our lives. Energy sources are broadly divided into two categories, namely renewable, an energy source that can use over and over again, and non-renewable resources when the energy source cannot be reused. Renewable resources. Renewable energy is the term used to describe energy that comes from sources whose supplies are regenerative and virtually inexhaustible. Renewable energy sources can be replenished in a short period of time. Some of the renewable sources are first is the solar energy. The most common energy received on our planet Earth is the direct sunlight. Solar energy is inexhaustible and it comes to Earth in the form of visible light and infrared radiation. We have always used the energy of the sun as far back as humans have existed on this planet. Decaying of plants hundreds of millions of years ago produced fossil fuel, which includes coal, oil and natural gas. Thus, what we use today is actually sunlight stored millions and millions of years ago. Solar energy can be harnessed in a variety of ways to heat homes, heat water, grow plants and produce electricity. Solar power includes active, passive and photovoltaic technologies and practices. Second is the biomass energy. Biomass energy or bioenergy is the energy from organic matter such as firewood, twigs, dead plant parts, cattle dung, livestock, manure and dead animal matter. Plant leaves convert sunlight into chemical energy which is stored in the plant. So, you can see the different types of biomass. Animals that eat the plant store chemical energy in their bodies. Some of it also remains in manure and other wastes. Biomass fuels are renewable because the raw material can be produced simply by growing more crops or collecting more organic waste. The use of renewable energy is not new. Traditionally, wood has been as the main source of energy for thousands of years, ever since people started burning wood to cook food or to keep warm. Even today, firewood and crop residues from the largest biomass energy source and is used by rural communities and forest dwellers. Biogas can be produced from cattle dung, human feces and other organic waste by process called anaerobic digestion in biogas plant. Biogas is a clean, non-polluting and low-cost fuel. Biogas fuels are obtained from agricultural wastes like the crops, alcohol fuels, animal waste and municipal solid waste. Now, the biomass which would normally present a disposal problem is converted into electricity. For example, manufacturing wastes, rice hull and black liquor from paper production. Many other sources of biomass can now be used, including plants, residues from agriculture or forestry and the organic component of municipal and industrial wastes. Nowadays, alternatives of using biomass are still being discovered. One way is to produce ethanol, a liquid alcohol fuel from biomass. Unlike other renewable energy sources, biomass can be converted directly into liquid fuel, which is called as biofuels for our transportation needs, cars, trucks, buses, aeroplane and trains. The two most common types of biofuels are ethanol and biodiesel. So, biodiesel. Biodiesel is obtained by trans-etherification of the vegetable oils. Oil-rich seeds of the wild plants, which are rich in non-edible oils, are potential source of biodiesel. Seeds of Pongamia, Jatropha, neem, they are favorite for producing biodiesel. Consumer demand for clean renewable energy have stimulated growth in green power, solar, wind, geothermal steam, biomass and hydroelectric sources of power. Hydropower. Flowing water creates energy that can be captured and turned into electricity. This is called hydroelectric power or hydropower. Hydro energy from water is also a renewable energy source. Hydroelectric energy or hydropower is energy which is produced by the action of falling water, turning a water wheel, propeller or turbine. Almost all hydroelectric energy is used to produce electricity, although early pioneers built water wheels to grind grain and operate other machinery. The most common type of hydroelectric power plant uses a dam on a river to store water in a reservoir. Another type of hydroelectric power plant is called a pumped storage plant that can even store power. Hydroelectric power plant. The power is sent from a power grid into the electric generator. The generators then spin the turbines backward, which causes the turbines to pump water from a river or lower reservoir to an upper reservoir where the power is stored. To use the power, the water is released from the upper reservoir back down into the river or lower reservoir. This spins the turbines forward, activating the generators to produce electricity. Some hydroelectric plants or micro hydroelectric power system doesn't necessarily require a large dam, but just a small canal to channel the river water through a turbine which can produce enough electricity for home, farm or a small village. Wind energy. The kinetic energy of the wind can be changed into other forms of energy, either mechanical energy or electrical energy. When a boat lifts a sail, it is using wind energy to push it through the water. This is one form of energy. Farmers have been using wind energy for many years to pump water from wells using windmills. Wind energy is a clean renewable energy source produced by the daily cooling and heating patterns on the surface of the earth. Wind energy can be harnessed to produce electricity, pump water, grind grain and move sailing vessels. Wave energy. Ocean and sea waves are caused indirectly by solar energy. Wave energy is derived from wind energy, which is driven in turn from solar energy. Wave energy may be converted to mechanical energy and then to electricity. The next is the ocean thermal energy conversion. Conversion of solar energy is stored as heat in the ocean into electrical energy by making use of temperature differences between the warm surface water and the colder deep water. Then geothermal energy. Geothermal energy refers to energy contained in underground rock and fluids. Thermal or heat energy deep within the earth may heat water or form steam. Geothermal energy is used to power steam turbines and generate electricity, although it can be used to heat homes and other buildings. This heat is a result of the increase in temperature of the earth with increasing depth below the surface. It is the energy which comes from the earth, that is the energy contained in underground rock and fluids. Geothermal energy is responsible for heating of water of hot water springs. Then fuel cell technology. Fuel cells are devices that directly convert hydrogen into electricity. Hydrogen is a colorless, odorless gas found on earth only in combination with other elements such as oxygen, carbon and nitrogen. To use hydrogen, it must be separated from these other elements. Hydrogen as a fuel is high in energy and a very promising clean fuel. A fuel cell converts hydrogen, which is produced and stored, and oxygen from the air into electricity. Fuel cells are a promising technology for use as a source of heat and electricity in the buildings and as an electrical power source for vehicles. Large amount of energy is needed to produce hydrogen from water, so it will not come into its own as a clean alternative until renewable energy is widely available for the process. In the future, hydrogen could substitute electricity as an important energy carrier. An energy carrier stores, moves and delivers energy in a usable form to consumers. Renewable energy sources like the sun cannot produce energy all the time. The sun does not always shine, but hydrogen can store this energy until it is needed and can be transported to wherever it is required. Now we come to non-renewable energy. Non-renewable energy resources have limited amount of stocks available. The regeneration rate of non-renewable energy resources is negligible when compared with the rate of consumption. That is, non-renewable energy that we are using up cannot be recreated in a short period of time or at least in our lifetime. Fossil fuels are important energy resource. Fossil fuels are found under the ground and below the sea floor in liquid and gaseous form. Fossil fuels are the remains of ancient plant and animal life found on earth. Fossil fuel energy is released in the form of heat. So, in this we will deal with first oil, or we also call it as petroleum. Oil is a liquid fossil fuel that is found under the ground and below the sea floor. Fossil fuels were formed before and during the time of dinosaurs when plants and animals died. Their decomposed remains gradually changed over the years to form coal, oil and natural gas. Oil and natural gas is formed by complex decay processes from microscopic life forms called phytoplanktons, which floated in the world's oceans millions of years ago. Just like today's phytoplankton, they harnessed and stored the solar energy through the process of photosynthesis. Zooplanktons are tiny animals which eat phytoplanktons, but themselves are the main food for fish and some whales. Hydrocarbons are simple molecules made up of carbon and hydrogen atoms joined together in chains or in rings. These molecules, being light and mobile, migrated upward through the rock, but eventually became trapped beneath the impermeable rock structures in the earth's crust. Petroleum is one of our most vital resources. During the past 30 years, consumption of petroleum has grown more steeply than other energy sources. Petroleum provides about 40% of the commercial energy used in the world. Fossil fuels took millions of years to form. We are using up the fuels formed more than 65 million years ago. They cannot be renewed and they cannot be made again. Second in this is the natural gas. Natural gas is also fossil fuel, that is a mixture of gases natural found under the ground. Natural gas is collected and transported almost the same way as oil. Natural gas burns in home furnaces and cooking ranges. It is now being used in cars and buses for transportation. Coal. Coal is the most common solid fossil fuel which was used as a primary source of energy in homes and industry. It is found under the ground in solid form and have to be mined and transported for use. Our country has large coal reserves. Coal is mostly carbon but contains small amounts of sulfur. It is formed from plants, mostly trees which grew millions of years ago in low-lying swamp areas. When these trees die, they sink to the bottom of the swamps. In the swamps, they did not rot fully as there was no air. Partially decayed plant matter in swamps and bogs is called peat, which has low heat content. These peat get covered by sand and mud as water subsides. More material is deposited on them years and the plant matter gets converted into coal under pressure and heat. Then we come to the nuclear energy. Nuclear energy is liberated from a nuclear reaction, fission or fusion, or by radioactive decay. In a conventional nuclear reactor, isotopes of uranium and plutonium undergo controlled nuclear fission. The resulting heat produces steam that in turn spins turbines to generate electricity. Large fuel supply, low immediate environmental impact, low emission of carbon dioxide, low chances of accidents because of multiple safety systems makes this energy a much wanted resource. Unlike other energy resources, nuclear energy produces highly radioactive materials that must be kept safely for thousands of years until their radioactivity falls to safe levels. Also, when the useful life about 40 to 60 years of a nuclear reactor come to an end, it cannot be shut down and abandoned like a coal burning plant. It contains large quantity of radioactive materials that must be kept out of the environment for many thousands of years. The safety features make nuclear power plants very expensive to build and maintain. However, management of the nuclear waste disposal, its vulnerability to terrorist attacks and misuse to the technology for making nuclear weapons makes it difficult choice and it remains world's slowest growing energy resource. Now we come to the worrying signs. A couple of centuries ago, virtually everyone would have depended on the fuel they could find within a short distance from home. Now the fuels required for heat and light travel vast distances to reach us, sometimes crossing not only continents but political and cultural watersheds on the way. These distances create a whole host of challenges, from oil related political instability to the environmental risks of long distance pipelines. Also, we cannot use fossil fuels forever as they are non-renewable and finite resource. The International Energy Agency says the world will need almost 60% more energy in the year 2030 than in 2002, and fossil fuels will still meet most of its needs. Not everyone depends on the fossil fuels. Nearly a third of today's world population has no electricity or other modern energy supplies, and another third have only limited access. However, we can also get energy to do several jobs at once, as combined heat and power plants do, and we can use less of it by becoming energy efficient. Cheap available energy is essential for ending poverty. Ending poverty is a key to easing the pressure on the planet from the poor who have no choice but to eat the seed corn. Our energy use is unsustainable, but we already know what a benign alternative would look like. but large amount of energy are needed to produce hydrogen from water. So, it will not come into its own as a clean alternative until renewable energy is widely available for the process. So, I think I can summarize the topic by saying that we have to conserve the energy. There are two sources of energy, renewable and non-renewable, and we should use them judiciously. That is all I can say. Thank you.
Thank you, Dr. Pajmada Saxena, for sharing information related to importance of energy in our society. Dear learners, before we wrap up, we would like to recap the main points, that is what you have learned. Energy is defined as ability to work, or power is to rate the energy delivery. It is required by all living organisms, including humans. Nothing can move or work without the use of energy. The behavior and transformation of energy is strictly governed by the laws of thermodynamics. The first law of thermodynamics states that the energy can neither be created nor destroyed. The second law of thermodynamics states that energy transformation are never 100% efficient, that is, at each step of energy transformation, some amount of energy is lost as waste heat. The conventional unit of measuring energy is gram calorie. The various sources of energy are broadly divided into two broad categories, namely renewable and non-renewable. Renewable energy is termed used to describe energy that comes from sources whose supplies are regenerative and virtually inexhaustible. The most important and inexhaustible source of energy is the sun. Solar energy is harnessed by green plants by the process of photosynthesis for making food and the biomass, which is subsequently used as energy source by animals, including man. The other renewable resources of energy include solar energy, biomass, wind energy, hydroelectric energy, geothermal energy, and wave or tidal energy. Non-renewable energy sources have limited amount of stocks available. The regeneration rate of non-renewable energy sources is negligible when compared with the rate of consumption. Fossil fuels are important non-renewable energy source. Fossil fuels, that is coal, lignite, peat, gas, oil, are found under the ground and below the sea floor in liquid and gaseous form. Fossil fuels are the remains of ancient plants and animal life found on earth. Fossil fuels energy is released in the form of heat. Fossil fuel is hydrocarbon and they include coal, lignite, peat, petroleum and natural gas. There is growing emphasis to promote the use of renewable energy resources to reduce our dependence on fossil fuels because the latter will exhaust it soon. Growing use of fossil fuels has increased the amount of carbon dioxide in the atmosphere, leading to global warming and climate change. Dear learners, this is all about importance of energy in society. We will come again to meet you with a new program of environmental science. Thank you.